Express the rational number 19 over 27, or 19/27ths, as a terminating decimal, or a decimal that eventually repeats. Include only the first 6 digits of the decimal in your answer. Let me give this a shot. So we want to express 19 over 27, which is the same thing as 19 divided by 27, as a decimal. So let's divide 27 into 19. So 27 going into 19. And we know it's going to involve some decimals over here because 27 is larger than 19 and it doesn't divide perfectly. So let's get into this. So 27 doesn't go into 1. It doesn't go into 19. It does go into 190. And it looks like 27 is roughly 30. It's a little less than 30. And 30 times 6 would be 180. So let's go with it going 6 times. Let's see if that works out well. 6 times 7 is 42. 6 times 2 is 12, plus 4 is 16. And when we subtract 190 minus 162 is going to get us, actually, we could have had another 27 in there, because when we subtract, so we get a 10 from the tens place, so that becomes 8 tens. This became 28. So we could have put one more 27 in there. So let's do that. So let's put one more 27 in there. So 7 27s. 7 times 7 is 49. 7 times 2 is 14, plus 4 is 18. And now our remainder is 1. We can bring down another 0. 27 goes into 10 0 times. 0 times 27 is 10. Subtract, we have a remainder of 10. But now we get to bring down another 0. So let's bring down this 0 right over here. So now 27, it goes into 100 3 times. 3 times 27 is 60, plus 21 is 81. 81. 3 times 7, yep, 21. Yeah, 81. And then when we subtract 100 minus 81, well, we could take 100 from the hundreds place and make it 10 tens. And then we could take one of those tens from the tens place and turn it into 10 ones. And so 9 tens minus 8 tens is equal to 110. And then 10 minus 1 is 9. So it's equal to 19. You might have been able to do that in your head. And then we have, and I see something interesting here, because we bring down our next 0. We see 190 again. We saw 190 up here. But let's just keep going. So 27 goes into 190. We already played this game. It goes into it 7 times. 7 times 27, we already figured out, was 189. We subtracted. You had a remainder of 1. Then we brought down another 0. Bring down another 0. We said 27 goes into 10. 0 times. 0 times 27 is 0. Subtract. Then you still have the 10, but we got to bring down another 0. So you have 27 goes into 100. We've already done this 3 times. So you see something happening here. It's 0.703703, and we're just going to keep repeating 703. This is going to be equal to 0.703703, on and on forever. So the notation for representing a repeating decimal like this is to say this is 0.703, and you put a line over the part that's going to repeat. So you put a line all over the 7, the 0, and the 3. So this means that the 703 will keep repeating on and on and on. So let's actually input it into the exercise now. So it's 0.703703, and they tell us to include only the first 6 digits of the decimal in your answer. And they don't tell us to round or approximate, because obviously if they said round to that smallest 6th decimal place, then you would round up because the next digit is a 7. But they don't ask us to round. They just say include only the first 6 digits of the decimal in your answer. So that should do the trick, and it did.